recording, and we're going over our lab from the other day. I know this got cut off, so it should say mechanical, chemical, and then erosion. So our first lab was when we rubbed the Q-tip against the cookie, and then we put it in the water. So when you use the Q-tip to weather the chocolate chip, if I were you, I would have broken down what the word weather means. I'm not talking about precipitation here, right? What did I mean by the word weather? What did I mean by the word weather, Samantha? To break it down, yep. Because physical and mechanical weathering, they're the same thing. And it breaks rock into smaller pieces. And chemical weathering change the materials and also break that rock. So what did you observe when you were rubbing? And if you're missing something on your lab, fill it in, right? That's why we're going over it. What did you observe when you were rubbing the Q-tip, rubbing the cookie with the Q-tip? Anybody? I'm about to start randomly calling on people. Jayla, what did you notice? So can we describe what that looked like though? What did it mean it was slowly weathering away? Okay, good. So I could say when I rubbed the cookie with the Q-tip, the cookie began to break and crumble. Now remember, my expectation is that you're writing in full sentences here. If you just write crumble, I'm taking points off. We're sixth graders, right? So I want you guys to practice because as you guys get older, there are going to be lab sheets for and they're like pages long. So you have to be prepared, right, for what's going to be expected from when you're older. So just make sure you're practicing the right thing. What kind of weathering did that represent? Was it mechanical or chemical? Mechanical or chemical? Cat? Mechanical. What kind of mechanical weathering specifically? Abrasion. Perfect. So I could say this represented mechanical weathering comma, specifically abrasion. And let's define abrasion. So I'll say the cookie represented, what did the cookie represent in this? A rock. And the Q-tip. So why was this abrasion? Tell me what abrasion is. I will wait and you will not get to your study guide. Where is everybody today? I don't want the same people anymore. Ariel. What is abrasion? Sediment? No, it has to do with rubbing. What is abrasion? Jayla? Something like going on one side and nothing. Okay, so what's another word an F word that begins with that? Or an F word that means the same thing? Cat. Friction. Friction. So the Q-tip, we could say, was grinding and rubbing the cookie, rubbing against the cookie. causing friction/abrasion. So you can see how I defined what abrasion is by talking about how it was like that rubbing and grinding, right? Very similar to friction, yes. Where's your lab sheet?
I had a folder. I put it in a folder, but I had to.
So you need to go get a new one and you're starting over. So there's a new one in the brown bin. And you need to answer what we've already answered and then you can use the restroom. How did the water contribute to the weathering? How did water contribute, Layla? Good, so the water broke down the remaining pieces of the cookie. Specifically, what method? What method, Sam?
Dissolving.
By dissolving it. Good. Was this representing, by this I mean the water, right? Did that represent mechanical or chemical? Savannah? Good, and why? Perfect. I can also explain why by defining what chemical is, right? So what is chemical weathering?
When it changes something into a new substance.
Very good. So the water represented chemical weathering. Because when I dissolved the cookie, or when it dissolved the cookie, it created a new substance. So do you see how I defended my answer by restating what chemical weathering was? I create a new substance. Your answers should look something like that. It doesn't have to be word for word, but if you look at my overall lab sheet, I would be able to see that you absolutely understood the purpose of that specific station, because you were able to explain what mechanical weathering was, what abrasion was, what chemical weathering was, and how the water represented that. So I'll give you a second to catch up if you need to. Remember, the more you put into something, the more you're going to get out of it. So the more you put into this lab, the more you're going to get out of it, the more understanding you're going to get out of it afterwards. Did you adjust yours? Okay. I'm going to give you about 10 more seconds. All right, so let's flip to our chart for station 2. Remember, I accidentally stapled these backwards, sorry. And your data may have been different, but you should have all noticed the same trend. So your first, when you took the mass of the candy at first, and my mobile friends, I know you didn't have the mass because you didn't have a scale, so you can copy our class data, but it should have started around 4.4 grams, right? Did anybody get something similar? 4.4, 4.3, 4.6, 4.5. And they looked like whole pieces of candy, right? What about after the first 20 shakes? Somebody tell me what your mass was, Fiona? 3.8. You may have had something similar. Remember, don't change your data. If your data said something different, that's okay. You will still notice the same overall trend though. And then what started happening to the physical appearance, Alex?
It started to lose all of its color.
So I'm just gonna write losing color.
Yeah, because there were still little spots of color.
Yeah, there might have been still some color, but again, because I'm not using colored pencils, I'm just gonna write full M&Ms so that I'm writing a physical description. What about after 40 shakes? So this was an additional 20. What did you notice, Trey?
Yeah, they started to turn just
So they were brown?
They were almost.
Brown / maybe a little bit of white left?
Yeah, they were white.
And what was the mass? What was your mass, Sam?
It was 3.2 grams.
3.2 grams. Okay. Again, don't change your data if yours was different. My mobile friends, because you didn't have the mass, I'd like you to write the data we're coming together to obtain as a class. What about it after another 20 shakes? Another 20 shakes. Lucas.
It was completely chocolate and
So all brown, were they the same size or were they any
they
smaller?
were the same size.
Same size.
3.2 hard to read.
And then what was the mass you had for that one? 3.2, that's okay. So you might have noticed that for some trials it might have been the same mass, right? And that's okay. But what about after another 20 shakes? Let's get somebody who I haven't heard from about their data. Jasmine? 2.2? And then was it any smaller in size, do you think? So they were still all brown. But do you think that they were any smaller than a normal size M&M? Did it look like maybe part of it had melted off?
I don't know.
Anybody notice that? So slightly smaller. And then what about after the 2.2? Did anybody notice that theirs got smaller than that?
Yeah, it was smaller.
So it was smaller,
Like a little bit.
all brown.
2.3.
Did anybody's get their last one? Did anybody end up at 2.2 for their last trial?
We had 3 grams.
3 grams. 2.3.
No, we got 2.9 because we forgot.
3.5. So Jasmine, what did your group get after the last 20 shakes? You didn't get that far? Okay, so I'm going to leave it at 2.2 because it can't gain mass back, right? So again, this is collective data. We could very well take the average of each trial and graph it, right?
Yeah.
But what was our overall trend?
They got smaller and lost their color.
Good, so their size got smaller, color loss. And then what happened to the mass?
They got smaller.
We're gonna say it decreased. So again, if your data was different, don't change your data. This was just what we're gathering as a class. And our observations showed that they were slowly getting smaller. Now, if you turn back to the first page, to the front of this page where there's the blank lines, it talked about describe in detail how they changed throughout the experiment. So we kind of did that, right? We said the M&Ms got smaller in size and decreased in mass. And I want you guys to add something for me. Let's talk about what this specific station represented. What did this specific station represent? Joseph?
Dissolving.
Okay, dissolving, so a type of weathering. But what did the jar represent?
I would say either erosion or deposition.
Okay, so erosion, definitely erosion. Erosion in what, Kat?
Like a river?
A river, very good. So we could say this station,
Because the M&Ms were rocks and they were hitting up against like the bottom of the
exactly. So this station represented erosion in a river. Just like Sam said, the M&Ms represented rocks.
And the jar represented the bottom of the river.
Yep, and we'll say the current of the river, right? And the jar represented the current of a river. Now, I hope that this proved to you that while rocks are being eroded, remember, erode, like we drive on a road, rocks move on a road. So while they're being moved, they can also be weathered at the same time. Does anybody remember what this is called? It begins with an R and it's also a math term.
What?
Trey?
Reverb?
No. It's another, abrasion is an example, but it's when rocks slowly get smoother and their shape changes. We talked about skipping rocks. Cat? Rounding. Very good. So I want to write that rocks can be weathered while eroding. So weathered through abrasion and dissolving. While being eroded. This is called rounding. So I know that I didn't ask you to write that initially, but I want you to understand the purpose behind this experiment. So our detail is that the M&Ms got smaller in size and decreased in mass. This station represented erosion in a river. The M&Ms represented rocks, and the jar represented the current of a river. Rocks can be weathered through abrasion and dissolving while, meaning at the same time, as being eroded or moved. This is called rounding, when rocks bump and grind against each other to knock off all the sharp parts and only leave a rock that is smooth and round. Yes, Trey? Yes. Make sure you have this first, okay? Because I'm going to switch my page. Okay. Thumbs up when you guys are ready. Awesome.
Miss Burley,
Love?
so me and Brianna never got to finish our science project, and we never printed out this paper. So we didn't get to do the last one, and we didn't print out the paper, so we have everything in our journals.
That's okay. Just send me a picture of the journal. That's fine.
Okay.
I'll also upload to my YouTube channel, so if you missed anything, you can copy it from there. Oh, I just saw you guys' your chat. You can absolutely use science and architecture. Remember we had that test question that asked about about the skyscrapers? Scientists do that all the time. So they have, like, engineers are a type of scientists.
Really?
So you have engineers as well, and engineers are going to help you to design, whether it be mechanical engineering or civil engineering, but they work with architects to help design things for cities that are going to be successful, right, based off of the circumstances of the city. Sorry, I just saw the chat. And yes, you can fill this out now. I am going to move on to our last section so we have time to work on our study guides. I like it. All right. Play-Doh. I know again that this seemed like just like a silly little activity, but it got the purpose across. So when you filled up the bottom of the whole little tray with little pieces of Play-Doh, right? And you kind of smushed it down and it was deposited and flipped it over, it should have formed a landform, right? Define deposition in your own words. Can I have someone, one of my mobile friends who hasn't participated yet? Go ahead, Samantha. You're on mute, love.
Deposition is layers of sediment build up and create landforms over time.
Okay, so deposition is when sediment forms layers. I'm gonna say when sediment settles and forms layers that build landforms. So sediment is that leftover pieces, and you guys should have realized that when you did the abrasion against the cookie, that formed sediment, right? And then as it was moved, it got smaller, right? And then the deposition should have made you realize that sediment. What did the Play-Doh represent? Daniel, what did the Play-Doh represent in the experiment?
The Play-Doh represented the sediment.
Very good. The Play-Doh represented sediment. How are landforms created by deposition made, Ryan? How are they made?
Rocks build up the mountains.
Well, they're not mountains, right? Because they're never going to be a mountain. But I did like how you say they build up, right? So we could say sediment is deposited and build up or builds up over time. And then what do those landforms look like? They're not tall, right? They're not tall. If they were tall, like, I mean, it might form a hill, right? Maybe a hill, but never like a whole mountain. Mountain ranges are formed by tectonic plates coming together. So it might have formed a hill or sand dune or sandbar. But they're typically what? Flat and low lying. Very good. So I'm going to restate my question. Landforms formed by deposition are typically flat or made up of, appear to be made up of layers, right? Examples. Give me some examples of landforms made by sediment, Alex.
The Florida Keys.
You mean like the islands? Or the, so islands can be made up of sediment?
But is that really?
Islands are landforms. But what have we been talking about so far, Sam?
Sandbar.
A sandbar? Give me another one. Brianna. We will not learn about tectonic plates this year. You learn about tectonic plates next year.
Sand dune?
Oops, I didn't mean to do that.
She said sand dunes.
I see. I paused our. Okay, sand dunes. What else did we talk about? One that's at the mouth of a river, Jayla. Huh? Hills. Okay. Lucas. A delta. I forgot to write island. Some islands are made from deposition, like remember with the parrotfish? But not all islands. Some islands are a result of tectonic plates or erosion when the coast is eroded and separates the pieces of land. But volcanoes can form islands, right? And that's deposition because the lava is depositing, right, to form a new landform. And there's one more that begins with an A, has a weird name. A riverbed. And
It's like empirical fan.
close, an alluvial fan. Remember, these are all constructive. These are all constructive landforms. They look like somebody built them up over time. Whereas erosion and weathering are destructive. That was the last page.
Why do we have to?
Why does what?
Why did you have
Okay, sorry, I just couldn't hear you, baby. Go ahead and make sure your name is on this
Miss Burley?
because I am going to collect it. My mobile friends, you need to be submitting yours via Schoology. I will give this back to you before your unit test so you have the ability to study it. I hope that this, thumbs up if you think that this hands-on experience helps you to understand the difference between weathering, erosion, and deposition. Okay, good.